We are celebrating the bravery, sacrifice, and dedication of the men and women of the Indian Army. Established on January 15, 1895, the Indian Army has a long and proud history of defending the nation and upholding its values. Throughout its history, the Indian Army has faced numerous challenges and conflicts and has always emerged victorious. From the First and Second World Wars to the wars with Pakistan and China, the Indian Army has shown unparalleled courage and determination in the face of danger. The Indian Army has also played a vital role in peacekeeping operations around the world and has contributed significantly to the maintenance of international security and stability. On this day, we honor the sacrifices of the soldiers who have lost their lives in the service of the nation and pay tribute to the brave men and women who continue to serve with distinction. We also recognize the contributions of the families of soldiers, who provide unwavering support and love to their loved ones in uniform. The Indian Army is a symbol of national pride and unity, and we are grateful for all that it does to protect and defend our nation. On the occasion of Indian Army Day, we present a few mathematical facts that may be relevant to strategic Army deployment. Graph theory is used to model the movement and positioning of military units, as well as to analyze the efficiency of different deployment strategies. Along with it, game theory is used to study decision-making in any armed conflict, including the selection of tactics and strategies. Operations research techniques, such as linear programming and network optimization, are used to analyze logistics and supply chain management in the military. Geographic information systems, GIS, and spatial analysis techniques are used to analyze and visualize the geographical aspects of an operation. In addition to that, probability and statistics are used to analyze and predict the outcomes of military action, as well as to assess the effectiveness of different tactics and strategies. Let us look into them one by one. Graph theory. Graph theory is a branch of mathematics that deals with the study of networks and graphs. In the context of military strategy, graph theory is used to model the movement and positioning of military units, as well as to analyze the efficiency of different deployment strategies. By representing each military unit as a vertex, or node, in a graph and the relationships between them as edges, it is possible to analyze the flow of information and resources between units, as well as the overall structure of the military organization. This can be especially useful for analyzing the effectiveness of communication networks and logistics chains within the military. In addition, graph theory can be used to analyze the strength and vulnerabilities of different deployment configurations, as well as to optimize the placement of units to maximize their effectiveness. For example, by analyzing the connectivity of different vertices in the graph, it is possible to identify key points that may be more critical for the overall operation, and allocate resources accordingly. Overall, the use of graph theory in military strategy allows for a more structured and analytical approach to deployment planning, enabling military leaders to make more informed decisions about the allocation and positioning of their units. Game theory. Game theory is a branch of mathematics that deals with the study of strategic decision-making. In the context of military conflict, game theory is used to analyze and predict the outcomes of different tactics and strategies, as well as to understand the decision-making process of military leaders and their adversaries. One of the key concepts in game theory is the idea of a game, which is a model of a strategic situation in which two or more parties, called players, make decisions that affect one another's outcomes. By analyzing the different options available to each player and the likely outcomes of those choices, game theory can help military leaders understand the trade-offs and incentives involved in different courses of action. For example, game theory can be used to analyze the effectiveness of different military tactics, such as the use of ambush or surprise attacks, and to predict the likely responses of an enemy. It can also be used to study the decision-making process of military leaders and the factors that influence their choices, such as the availability of resources or the relative power of different parties. Overall, the use of game theory in military conflict allows for a more systematic and analytical approach to decision-making, enabling military leaders to make more informed choices about tactics and strategies. Operation research. Operations research is a discipline that uses mathematical and statistical techniques to analyze and solve complex decision-making problems. In the context of military logistics and supply chain management, operations research techniques, such as linear programming and network optimization, are used to analyze and optimize the flow of goods, materials, and information within the military organization. Linear programming is a mathematical technique that is used to optimize the allocation of resources in order to achieve a specific objective. For example, it can be used to optimize the distribution of military supplies to different units, taking into account factors such as the availability of resources, transportation costs, and demand. Network optimization, on the other hand, is a set of techniques that are used to analyze and optimize the flow of goods and materials through a network of locations, such as warehouses or distribution centers. By analyzing the flow of materials through the network, it is possible to identify bottlenecks and inefficiencies and develop strategies to improve the overall efficiency of the supply chain. Overall, the use of operations research techniques in military logistics and supply chain management allows for a more structured and analytical approach to resource allocation and distribution, enabling military organizations to optimize the flow of goods and materials to meet the needs of their operations. Geographic Information Systems, GIS. Geographic Information Systems, GIS, and spatial analysis techniques are tools that are used to analyze and visualize the geographical aspects of an operation. GIS is a computer-based system that is used to capture, store, manipulate, and analyze spatial data, while spatial analysis is a set of techniques that are used to study the relationships between geographical features and patterns. In the context of military operations, GIS and spatial analysis techniques are used to analyze and visualize the geographical aspects of an operation, such as the distribution of military units, the availability of resources, and the location of threats or targets. By analyzing these factors, it is possible to develop strategies and tactics that are optimized for the specific geographical context of an operation. GIS and spatial analysis techniques can also be used to analyze and visualize the impact of an operation on the surrounding environment, such as the potential for collateral damage or the displacement of civilians. This can help military leaders to develop more informed and responsible plans for their operations. Overall, the use of GIS and spatial analysis techniques in military operations allows for a more data-driven and analytical approach to decision-making, enabling military leaders to better understand and optimize their actions for the specific geographical context of an operation. Probability and statistics. Probability and statistics are branches of mathematics that deal with the analysis and prediction of outcomes and trends. In the context of military operations, probability and statistics are used to analyze and predict the outcomes of different tactics and strategies, as well as to assess the effectiveness of those actions. For example, probability and statistics can be used to analyze the likelihood of different outcomes of a military operation, such as the success or failure of a mission, the casualties that may be incurred, or the impact on the surrounding environment. By analyzing these factors, military leaders can develop more informed and realistic plans for their operations. In addition, probability and statistics can be used to assess the effectiveness of different tactics and strategies by analyzing the outcomes of past operations and identifying trends and patterns. This can help military leaders to identify the most effective approaches and to optimize their resources for maximum impact. Overall, the use of probability and statistics in military operations allows for a more data-driven and analytical approach to decision-making, enabling military leaders to make more informed choices about tactics and strategies. So let us take a moment to reflect on the sacrifices of the Indian Army and express our heartfelt gratitude for all that it does to keep our nation safe and strong. Happy Army Day, India!